Hey, so today we're going to talk more about the sides of triangles. So got a couple things, two things to add to your flipbook. So two different flipbook flaps. First one is how to find the range of the third side length of a triangle if you know two sides already. We'll talk about that in more detail. Just get the inequality written down here. And the next one would be how to determine if a triangle is acute, obtuse, or right. And so there's three inequalities, one that shows you it's a right triangle, one that shows you it's obtuse, one that shows you it's acute. So just get these copied down. It's going to make a whole lot more sense once we do some examples together. And just a quick note that a right triangle has 190-degree angle. An obtuse triangle has one obtuse angle, so that means it's one angle that's bigger than 90. And an acute triangle has all of its angles that are less than 90. So that's what we mean, or what I mean when I say a right triangle, obtuse triangle, or acute. So let's do an example here. I'm given two lengths of a triangle that I want to build. I want to build a triangle here with length 7 and with length 11. And so I want to find all the possible measures that I can use to build the triangle. So remember that the two smaller sides in a triangle have to add up to be more than the third side. So keeping that in mind, this is what we're going to do. We're going to add both of these sides together, because when I add these two sides together, if these are going to be the two smaller ones, then these ones added together need to be bigger than whatever my next side is. And the other thing we're going to do is we're going to subtract them. So I create this inequality that says 11 minus 7 is less than whatever my third side is, and that's less than 11 plus 7. So when I simplify both sides, I find out that my third side needs to be bigger than 4, and it needs to be smaller than 18. So my third side can be any number that's larger than 4 and smaller than 18. It can't be equal to 4, and it can't be equal to 18. It has to be bigger than 4, smaller than 18. So let's repeat that process. Here we want to build a triangle with sides 9 and 6. So on the left, I'm going to subtract 9 and 6. On the right, I'll add them. So I find out that my third side length, in order to build a triangle that has a side 9 and a side 6, the third side has to be bigger than 3, and it has to be smaller than 15. So quick note, just to show you again, if I had a side length in this triangle that was 3, and I added 3 to 6, it wouldn't be bigger than 9. So that's why my third side has to be bigger than 3. And again, it's got to be smaller than 15, because 9 plus 6 is 15. And so that sum has to be bigger than whatever my third side is. And again, we keep seeing this word range every time we're asking for the range of the third side. So that means you should have a number that it's bigger than, which is 3, and a number that it's smaller than, which is 15. So go ahead and pause here and find the range of possible measures for a triangle that has a side 12 and 11. So again, I'm going to subtract them and then add them. When I subtract, I get 1. When I add, I get 23. So that means our third side needs to be bigger than 1 and smaller than 23. And again, that's a range. We're finding a range. There's a whole bunch of possible third side lengths. And so that range is from 1 to 23. Bigger than 1, smaller than 23. The other thing I had you add to the flipbook is another type of inequality, and that is figuring out if a triangle is acute, obtuse, or right. And so we have this theorem, the Pythagorean theorem says that a squared plus b squared is equal to c squared. So let's see if I can write that. I just have my mouse. A squared plus B squared is equal to C squared. So that tells us how the sides in a right triangle are related to each other. If I take the two smaller sides and I square their lengths and add that together, if it's equal to the biggest side squared, then it's a right triangle. From back when you added to your flip book, I'm going to go back there. If I squared the two smaller sides and I add them together, and that's less than the biggest side squared, then it's going to make an obtuse triangle. If I add those two smaller sides together after I square them and that sum is bigger than the longest side squared, it's going to be an acute triangle. So essentially, we are plugging in numbers to the Pythagorean theorem, and we're going to see if the left side is equal, less than, or greater than the right side. So let's look at this first triangle on the left. My two smaller sides go on the same side of the equation together, so 9 and 12. So I'm going to do 9 squared plus 12 squared. I don't know yet if it's equal, less than, or greater than, so I put a question mark. My longest side is all by itself. I square all my numbers, 81, 144, and 225 is what I get. I'll simplify by adding 81 plus 144. And I find out that this left side is equal to the right side. So my two smaller sides, when I square them and add them, are equal to my longest side squared. So that is a right triangle. This middle one, my two smaller sides are 9 and 13. So those are the ones I'm going to have together. I'll square all my numbers. And I get this left side, my two smaller sides added together after they're squared. 81 plus 169 is greater than my longest side squared. So this ends up being an acute triangle. And on this last one, 6 and 8 are my smallest sides, so they're together on the left side of the equation. Square all my numbers. I get that my two smaller sides squared and added together is less than the longest side squared. So this is an obtuse triangle. So I want you to do one example of what we just did for those three triangles and figure out if this triangle shown is acute, obtuse, or right. Again, we're plugging into the Pythagorean theorem. My two smaller sides squared, added. I square all those numbers. And I figure out that this left side, my a squared plus b squared, the two smaller sides squared and added, is greater than the third side squared. So this is an acute triangle. So that's it for the lesson today. Make sure you put your tablet back, grab the practice, and get started.